The Grand Canyon Skywalk, a man-made engineering wonder that hangs over one of the world's great natural wonders and allows visitors to see the Grand Canyon in a whole new way.
Beautiful. It's frightening.
Beautiful. Oh my God, that is so scary.
Look at that.
Oh.
Awesome.
See how engineers build this amazing bridge, 4,000 feet above the Colorado River. This is the extraordinary story of the Grand Canyon Skywalk, wonder of the new millennium. "4,000 feet above the Colorado River, the Grand Canyon Skywalk appears to float on air. But don't be fooled. It weighs in at nearly 1 million pounds of steel and 64,000 pounds of glass. This walkway is heavy duty, built to withstand the forces of nature that created the natural wonder below. It took almost 4 years and more than $30 million to become a reality, and it doesn't disappoint.
It's breathtaking. It's unbelievable. It's just a crystal view. I think when you see eagles and other birds flying 1,000 feet below you, it's really awesome.
This spectacular human achievement combines state-of-the-art engineering and ancient technology to showcase the eternal beauty of the Grand Canyon. But its simplicity of form is deceptive. As a major engineering project, many obstacles challenged the creators of Skywalk. A beautiful but barren location, ancient geology, tribal controversy and environmental restrictions, ripping wind, and the fear of building a glass bridge over an enormous cliff just off the imposing west rim of the Grand Canyon. The Skywalk is located almost 120 miles east of Las Vegas, in one of the most desolate areas of the United States. A harsh climate contributes to the isolation. Temperatures range from 115 degrees Fahrenheit in summer to 28 degrees Fahrenheit in winter. Winds over 100 miles per hour have been measured, blowing through the canyon. This forbidding landscape is home to the Wallapai Nation. For decades, the Wallapai have opened their reservation to tourism to help support the tribe. But their main commercial enterprise, river rafting, is modest. In 1996, entrepreneur and developer David Jin approaches the Wallapai with a bold idea. He's a tour operator who's been bringing tourists to Wallapai sites for years. He proposes building something new to draw more visitors. A glass-bottomed walkway or observation deck, jutting out over the west rim of the Grand Canyon, complete with a visitor center.
I've been doing business with the Wallapai tribe for a long time, over 10 years, and I love this location. First is very close to Las Vegas. Second is they keep the Grand Canyon, just like, a few million years ago.
For the Wallapai, who own the land, Jin's proposal and the scale of tourism it would draw challenges a delicate balance between commercialization and preservation of nature. Within tribal families like the Watanamis, opinion is sharply divided. Should they build the Skywalk?
I said, well, we need to have income. We have to look at the needs of the people. So we had to change our ways.
In the beginning, I opposed the project because I grew up with this being a naturally beautiful place. And I thought that, building the skywalk where it is today, we infringed on the spirituality of the place.
On one hand, it's going to bring employment, help with the poverty situation. But on the other hand, perhaps desecrating the canyon in its natural state. So, it's mixed emotions.
After years of internal debate, the Hualapai approved Jin's proposal, with specific restrictions. No underground rooms or excessive excavation. No drilling into the face of the canyon wall. And color and texture of the structure must complement the natural environment of the canyon.
Aesthetically, we wanted the coloring, we wanted the formation to blend in with Mother Nature to the extent possible.
In October 2003, Jin hires architect Mark Johnson. While Johnson has years of experience in commercial and residential work, he recognizes the challenge. No one has ever designed anything like the skywalk.
I was kind of asked to help David Jin kind of create something, some sort of an experience that kind of captured the feeling that he had of the first time he was at the canyon when he watched the eagles soar through the canyon, almost effortlessly just floating through the canyon.
The original design is a simple plank extending a short distance over the edge of the rim. But very quickly, that evolves as they push the design envelope. It turns into something more innovative and challenging, a giant horseshoe-shaped bridge.
It got more and more extreme as we thought, wow, let's take this over the edge and maybe we could get it where you could look back to the actual canyon wall. Unlike you normally do, you usually stand on the edge of the canyon and you never see that backside. It's just not right. By that time, you've already fallen.
Drawing it on paper is one thing. Building it is another. Because engineers can only drill down from the top and not into the face of the canyon wall, the skywalk must be cantilevered from its foundation. This means that the structure extends horizontally over the edge, but without direct support from below. Cantilevered structures have been well known since Galileo's studies in the 17th century. But no one has ever built anything like this. A glass-bottomed platform extending 70 feet over a 4,000-foot precipice. To tackle this challenge, Johnson and Jin take their plans to Locksaw Engineering, the masterminds behind many recognizable hotels in Las Vegas, including the Wynn Resort, Mandalay Bay, and Caesars Forum shops. Locksaw also has experience building with glass. They designed the Shark Reef at Mandalay Bay. At Locksaw, Jin and Johnson meet engineer Bill Caron.
We finally got together and said, hey, do you think we could maybe shove this thing out 50, 60, 70 feet and not attach anything and have a big opening in the middle so you could feel like you were flying almost?
Caron is intrigued.
The first thinking was, this is pretty wild. It'll be fun to do, different, and it did have a big coolness factor.
While Johnson and Caron look over blueprints, developer Jin and the Hualapai pick out a location, a stunning site on the west rim. It is called Eagle Point because it looks across the canyon at a distinctive rock formation in the shape of an eagle. The spot is sacred to the Hualapai because they believe the eagle lifts their prayers to the Creator. Unlike the stair-step formations found in much of the canyon, here, the rock walls drop precipitously for the first 2,000 feet. In addition to the sheer rock face, this site offers tremendous views of the Grand Canyon and Colorado River. The team hires geologist John Peck to inspect the proposed location.
I went out in November and spent a day mapping the surface geology at Eagle Point. and the location was right adjacent to a major crack, an open fracture in the rock. I'm amazed that that has not fallen yet, that wedge of rock.
Peck immediately determines that the site is not suitable for the skywalk. But he spots a better location just a few hundred feet to the north. Here, he also finds fractures in the rock, but with a significant difference. The cracks, also called joints, angle away from the canyon, not toward it.
The joint surface is pitching toward the canyon, and you load that, it has a tendency to slip down toward the canyon, initiating what would be a rock slide. If they're tipped back away from the face, a much more stable situation.
Peck carefully maps the cracks in the new location to assess their ability to hold Skywalk's proposed weight of 1.2 million pounds, the equivalent of 3 747 jet airplanes. He finds the location suitable for Skywalk. It offers geologic stability with the same impressive views. Engineer Bill Caron now begins research for Skywalk's foundation. First, he tests the compressive strength of the rock. This is done by placing a sample of the rock in a vise-like machine that literally squeezes the rock until it is crushed. The red limestone at the site withstands an astounding 16,000 pounds per square inch of compressive pressure.
16,000 psi bedrock would be comparable to 4 or 5 times the strength of the average person's driveway or the concrete sidewalk in front of your home.
The high compressive strength of the red limestone rock tells Bill Caron that drilling will be difficult, but not impossible. He focuses on the next challenge: how to marshal the manpower, equipment, and resources to begin construction in such a remote location. This presents a whole set of problems similar to the building of Hoover Dam 70 years earlier.
We knew the site was remote, but the remoteness of the site has truly been a difficulty to overcome with most every aspect of the design and construction of the skywalk.
There's no electricity here. It will have to come from portable generators. There's no water. Every drop will have to be trucked in. And there are no facilities for human subsistence, so temporary arrangements will have to be made to feed and house the work crew. The nearest city, Kingman, Arizona, is 70 miles away. And construction vehicles must drive the last 14 miles on a difficult, unpaved, and deeply rutted dirt road to access the location. Successfully, Bill Caron and his team overcome these logistical obstacles. But they still face many unforeseen challenges to finally realize the dream of building the skywalk. Coming up, drilling stops cold when a hidden fracture threatens the entire project.
I thought it prudent to go over the cliff in a cage and to look at the joint system below the cliff.
The Grand Canyon Skywalk offers a unique perspective of one of the most visited places in America. Along with the canyon itself, the sheer force of nature is the star of the show. High winds often rip through the canyon, which helped carve the steep rock walls over past millennia. Since no one has ever studied the wind at this particular location, Locksaw sets up a weather station to gather data and measure the expected wind loads on the structure. They soon learn that velocities up to 90 miles per hour are common. These high winds create unique problems for the engineers and the cantilevered skywalk they are building.
There's nothing in the code that tells an engineer what to do with wind loadings right at the edge of the Grand Canyon. So that was one of the first challenging things that we faced.
Because the skywalk will hang 70 feet over the edge of a 4,000-foot cliff, high winds will hit it from multiple directions, from above, below, and across. This calls for special calculations.
The forces are huge, and we had to apply it in all three directions. Usually, when we analyze the wind, in addition to gravity loads, then we applied wind just one direction. I see. How about the perpendicular direction to that one?
The weather station also measures rates of erosion caused by wind, precipitation, temperature, and gravity. These elements can turn a hairline fracture in the rock into a gaping chasm.
And what happens there at the canyon is these rock falls, whether or not it's due to freezing and thawing in the winter or heating in the summer, finally the last grain that's holding the material up breaks up into pieces, and then the block falls. It's a very slow process, but it occurs in sporadic events. You might call this catastrophic events.
This kind of differential erosion accounts for the look of the terraced layers of the canyon walls over the last 1.5 million years. Given the strength of the bedrock and the need to minimize impact, the engineering team studies various options for Skywalk's foundation.
I got thinking it would be very difficult to attach it to the cliff, so I made the decision to bring it above the cliff and then lock it down to the top of the cliff and place the visitor center on top.
To lock the skywalk down to the top of the cliff, the team decides to build the foundation directly into the rock with caissons and micropiles. The 4 caissons are reinforced concrete columns. Micropiles are an engineered system of threaded steel bars that go inside the caissons, adding strength. Each micropile measures 2.5 inches in diameter and extends 46 feet down into the rock. This method of reinforcing a foundation is called post-tensioning. With the plan in place and work about to begin, the Hualapai blessed the construction site on October 1st, 2004. A month later, the tedious work of drilling begins, using diamond-tip drill bits and compressed air hammers.
Very difficult. Put it this way, I mean, they were breaking tips on the bit like every 5 to 10 minutes, they were breaking a bit. So that tells you how hard this rock was, and the material that we were trying to core through was extremely hard. Some of the hardest material that I've ever encountered.
As drilling proceeds, an unexpected and potentially devastating problem arises. The hole being drilled for one of the micropiles appears to be heading toward an intersection of 2 geologic cracks in the bedrock.
It was fairly evident that the chances of intersecting one of these joints by the drilling operation was fairly high. And as it turned out, they did intercept one of the vertical fractures, and some of the compressed air used in the drilling escaped along the fracture, which indicated that it might be open a little bit.
If the fracture opens too much, the entire project is in jeopardy. The builders might have to start over at a new location.
I thought it prudent to go over the cliff in a cage and take some measurements and to look at the joint system below the top of the cliff.
20 feet below the rim, John Peck finds the open fracture on the rock face. It reaches 13 feet into the canyon wall, just 3 feet from the hole being drilled for the micropile.
That caught everybody's attention.
The team decides to implement a rock bolting system inside the caisson to stabilize and reinforce the fracture. Using a grid of horizontal and vertical steel bars, they literally knit the rock together across its fracture pattern. This alleviates the pressure on the crack. The solution works. A crisis is averted, and drilling continues for the micropiles. Once in place, both the micropiles and the rock bolts are encased in concrete, along with 2 steel columns over each casing. These will become attachment points for the skywalk's structural frame.
So this is the foundation for 2 of the 8 columns for the skywalk, and basically it's a concrete cap that was poured on top of the micropiles and caissons below. And we also embedded this 2'8" square steel columns in the concrete to actually support the box beam skywalk itself.
A year and a half after drilling began at the location, skywalk contractors finished pouring the concrete foundation. David Jin and his family are there to celebrate the moment and mark the spot. The foundation is tested to assess its ability to support the projected load, and it exceeds all expectations. It measures over 71 million pounds, strong enough to support the equivalent of 71 fully loaded 747s.
We actually went overboard, I think, in some areas. So we did a lot of extra things according to the geologist's recommendations and the structural engineer's recommendations to make sure that it all went well, because this was never done before. This type of construction project was never done before.
Still ahead, building the horseshoe frame on land, then shoving it over a cliff and defying gravity. For the Hualapai, building skywalk is an important step to the future. But it's equally important that future visitors respect their past, their customs, and the land they call home.
Hualapai people have lived in this part of the world since the beginning of time. That's our belief.
It was natural, quiet, peaceful. They say the wind tells you things, and if you really listen, it does.
The Hualapai are traditionally nomadic. In the 19th century, the population of the tribe is decimated by war and disease. Their land is occupied by white settlers, forcing the Hualapai to live on a reservation. Established in 1883, it covers 1,500 square miles that reaches the edge of the South Rim. Since the 1950s, the Hualapai have tried various business ventures, but now focus on river rafting and West Rim tourism.
We don't have the other industry that other Indian tribes enjoy simply because of their location. But in a way, we're taking advantage of this location, and there's a delicate balance between nature and development for the Hualapai people.
In developing skywalk, the Hualapai are counting on the horseshoe-shaped bridge hanging over a huge cliff to bring in tourists and money. The key to making this happen lies in the beams that support it. Skywalk's major support beams are called box beams. These are giant, curved, hollow steel beams specially designed to handle huge loads of weight and stress. The box beams are 6 feet tall and large enough to walk inside.
These beams are 32 inches wide, 72 inches deep. They're made out of 2-inch thick steel plate, 50,000 psi. So it's a very strong steel plate, very large box beam section. Right here we have one of the cross beams, but this cross beam is to help lock the 2 beams together.
Another function of the box beams is to absorb vibration and avoid galloping in windy conditions. Galloping is a wind-induced movement on a support beam, which causes amplified oscillations and instability. In a worst-case scenario, galloping can cause catastrophic structural failure, such as the collapse of the Tacoma Narrows Bridge in 1940. This galloping was caused by modest 40-mile-per-hour winds. To prevent any galloping at Skywalk, where winds are significantly higher, the box beams are made with 2-inch thick steel plates. Their hollow design is engineered to flex in the wind and absorb vibration. The beams are custom fabricated in Utah in 40-foot sections and then trucked to the Grand Canyon. Shipping the box beams is a big endeavor. It takes months for all the sections to arrive at the location.
Once they were here, it's a matter of just turning the crew loose and going to work and putting them together.
For safety, the skywalk is assembled over land. It will be rolled out over the cliff later. First, permanent caps are attached to the 8 concrete columns. These will help anchor the skywalk. Next, the crew builds a network of temporary sawhorses to support the box beams as they are positioned for welding. Finally, the box beams are lowered into position using a large construction crane.
Really took a lot of precision in layout to put all the parts and pieces together. A curved structure that's 2 inches thick is not an easy thing to put together within 1/8 of an inch of accuracy.
After the sections are precisely aligned, welding begins on the million-pound structure.
They took quite a bit of welding, quite a bit of visual and x-ray inspections of the welds themselves to make sure that they adhered. A lot of time, a lot of months in welding that entire structure together.
It takes a month to weld the horseshoe-shaped frame together. With the structure complete, the reality of a cantilevered bridge jutting out over a 4,000-foot drop weighs heavily with Bill Caron.
One of the things I've thought about all through this project is I want people as they walk the bridge to feel safe and comfortable despite the fact they're walking on glass and looking thousands of feet down the face of a cliff.
The combination of wind and the weight of random foot traffic on the skywalk will cause vibrations on the structure, potentially frightening to visitors. This problem has to be solved. The answer is an engineering device called a tuned mass damper. Like shock absorbers, tuned mass dampers counteract vibrations by applying equal pressure and force in the opposite direction. Here, a weight mounted on springs counteracts wind and weight vibration. It stabilizes the structure and dissipates energy as heat, generated by the friction of the movement. 3 TMDs, each weighing 1.6 tons, are specifically calibrated to meet the wind and weight requirements of the location. They are placed inside the horseshoe-shaped steel frame, 2 inside the beam of the outer arc and 1 inside the beam of the inner arc. With these installed, the skywalk frame is now structurally sound. But still, no one knows how it will behave over the edge of the cliff. That test is still to come. Next, a monumental move, rolling skywalk over the cliff.
We were very, very nervous, very anxious. Hopefully it wouldn't fall in the canyon.
Years after the idea was first proposed, the horseshoe-shaped frame of the Grand Canyon skywalk is finished. and ready for the next step. Now it's time to add the defining element, Skywalk's unique glass floor. Engineers choose a glass made up of 5 layers. The layers are bonded together and laminated with a special adhesive to strengthen exposed edges and enhance clarity.
If they selected a glass and an interlayer product, it would give a very clear view.
Each pane measures 4 feet wide and 10 feet long and weighs about 1,200 pounds. While the steel frame of the Skywalk supports its own weight and that of the glass, each pane of glass has to support a live load of 100 pounds per square foot, or about 800 people. This far exceeds the 120 visitors allowed on the Skywalk at any given moment. To account for gravity and wind loads, the composite glass is measured to support downward forces of 100 pounds per square foot. Skywalk's glass walls were originally designed to 7 feet high. But engineer Bill Caron fears this will feel too confining for visitors. So he proposes a height of 5 feet 2 inches.
Now the code only requires it to be 42 inches tall, so we decided on 5'2", so we were a little bit safer than the code, but you don't feel confined when you walk the Skywalk. It's very open.
Visitors are required to wear cloth booties, but even so, small scratches and scuffing of the glass is inevitable. Fortunately, the 5-layer composite allows for periodic replacement of just the top layer, lowering maintenance costs. The machine used to move the large glass panes during the original installation and for replacement is called a manipulator. Powered suction cups on a crane-like arm pick up the glass. The glass is then tilted 90 degrees for one last cleaning. The operator then gently lowers the pieces into place. While the glass is very strong, it is also very heavy and can break under its own weight if it falls or collides with rock or steel. The sheer weight of each pane presents a problem as the engineering team prepares to install the glass walkway. Because the box beams bend slightly under weight loads, the team worries that as each pane is placed, it will cause the steel to bend and possibly break a pane that's already been installed. Any miscalculation can result in a shattered piece of glass. To counterbalance the frame during installation, workers set out a layer of temporary steel plates to simulate the weight and size of the glass panes.
So we actually emulated the weight of the glass as if it was on there. So we went around and put steel plate on each section as if it was a piece of glass. So as we put a piece of glass on, we take a piece of plate off to make sure we had the right balance of weight. So it basically had that same bend, if you will, with all the glass on it at the end of the day.
There's one final consideration in securing the sheets of glass. Spaced roughly 10 feet apart, the inner and outer box beams of the Skywalk move independently of each other. Over the course of a day, the heat of the sun and the weight of pedestrian traffic can cause the box beams to move, slightly shifting the glass panes up or down, creating an uneven surface. To solve this, small bearings are installed to compensate for height variations and provide a level foundation and cushion for the glass. With the glass in place, it's now time for the big moment, to roll the giant frame out over the rim of the canyon.
We were very, very nervous, very anxious. It was very, very intense to make sure everybody was on the same page on what we wanted to accomplish.
The rollout crew has been preparing for this moment for months. First, they raised the frame off the temporary sawhorses used during welding. Next, they lower the frame onto the rolling jacks that will carry the payload to its ultimate location.
We use the old Egyptian rod plate method where you move one plate, you move the rod to the next position, you roll it a little bit and you move it again.
The Egyptians used this rod and plate method to move heavy objects, like the blocks used to build the pyramids. At Skywalk, each section of the box beam frame is jacked onto a platform with a roll of rods underneath. The rollers minimize friction, so a relatively small force is needed to roll the structure in a straight line. 2 winch trucks are used to move the Skywalk. Pulley cables are attached to a temporary cross brace on the structure. These are attached to the foundation columns and connect back to the trucks. As the winches reel in the cables, the Skywalk inches forward over the canyon's edge.
We were going to move 1,571,000 pounds over the edge of the Grand Canyon without having to go over the canyon.
It's not just the weight of the Skywalk they have to move. The engineers worry that the frame might tip over the edge. So they pile 500,000 pounds of steel plates on the back of the frame to counterbalance the weight. The team also worries about a runaway once the rolling begins.
Pretty hard to stop 1.5 million pounds once it gets going.
So they borrow another trick from ancient Egypt.
We basically would throw sand in front of the rod, and actually what that created was a friction between the rod and the plate, and it actually stopped the Skywalk.
2.5 years after the groundbreaking ceremony, the Skywalk team is ready. The rollout begins. Inch by inch, the crew carefully rolls the Skywalk toward its ultimate position, 70 feet away. They get halfway there after a full day.
We had to roll it out without breaking any of it. So move it out approximately 70 feet at 1.5 million pounds without breaking any pieces of glass, and that was a feat in and of itself.
On the second day of the rollout, the methodical effort pays off. Skywalk reaches its final position. Now they have to secure it. The jacks gently lower the Skywalk on its foundation. As soon as the box beams are fitted over the 8 columns, welding urgently begins.
We then immediately started preheating the steel and running the beads, the weld beads. Well, each section, each side has 128 runs on top and on bottom, all the way around all 4 sides on all 8 columns.
The welders don't stop until the job is done. Then, the entire crew breathes a huge sigh of relief. The Grand Canyon Skywalk is secure and ready to be unveiled. When we come back,
She's about to break my arm.
opening day.
When you first walked it, you could hear a little crunching sound. So it's got a crunch, crunch, crunch.
After 2.5 years of construction and $30 million, the horseshoe portion of the Grand Canyon Skywalk is complete in March of 2007. Over 1 million pounds of steel and glass extend 70 feet over the canyon rim, suspended over 4,000 feet of pure air. An engineering marvel showcasing a natural wonder. Extensive testing with X-rays and ultrasound ensures that the structure is firmly tied to its foundation. It's time for the opening ceremonies. It's the moment of truth for everyone who has risked making Skywalk a reality. They begin with a blessing from the Hualapai spiritual leader.
All the tribal people came out. They were allowed to go on the skywalk. And the man that had the idea to put the skywalk here, David Jin and his family, and all the tribal members were here. And it was just very spectacular to have all those people together.
For the next 2 days, David Jin and the tribe welcomed the media and special guests, including astronauts Buzz Aldrin, the second man to walk on the moon, and John Harrington, the first Native American to fly in space.
This magnificent first walk bridges centuries of vision towards the future of hope.
The first step out on the skywalk, you really didn't know what you were going to experience. You couldn't see down the bottom right away. And then when you got on it, you looked down, and to see way down there sent chills and thrills down your spine.
You're actually walking on air when you walk out onto the glass floor and you look down and you basically see an endless sea of rock and beauty in the Grand Canyon.
When the gates open to the first customers, excitement mounts even more.
The one thing I would say was that if you were anywhere near this area, it would be a big mistake not to come here. It was definitely worthwhile. Definitely worthwhile.
And I thought I would be nervous or anxious or feel queasy. Not at all.
Visitors give their approval, but there is one cause for concern. A layer of cushioning foam between the glass and the steel beams provides an unexpected sensation on opening day.
When you first walked it, you could hear a little crunching sound. So it was kind of crunch, crunch. But as thousands of people have walked it, the crunching has gone away, thankfully.
Worry about crunching glass may be history, but the fear and butterflies of first-time visitors remains all too visible.
A lot of times, first-timers will do something like this. They'll tap the glass with their foot, gain a little confidence and step, carefully bring out their second foot. Then they'll test it out a little bit like this.
See, we're okay. Just one step at a time. See, that's how you do this.
Now, some people are frightened to walk right down the center, so they'll actually scoot over to the side, and you can see right above the bridge beam. You can't look down. You can put a death grip on the handrail and then kind of work your way down the skywalk.
Can I go through there? I know. It's so... I'm just going to stay here. Look at that.
No.
Awesome.
I'd read about it, but you don't ever know until you're actually on it how you're going to experience, what you'll experience.
Picturesque, it's absolutely beautiful.
Soon, a visitor center and restaurant will be added to the complex, resting on top of Skywalk's foundation, completing the vision of a unique tourist experience at the edge of the Grand Canyon.
The idea was just for folks to come enjoy the beauty of it all and have a bird's eye view, if you will.
Yeah, it's really far down.
It's a one-of-a-kind type of a structure that really gives you the beauty and the opportunity to look at the beauty of the Grand Canyon.
The Grand Canyon is spectacular. That's been one of the greatest things I've had to deal with this project.
Tourists from around the world visit the Skywalk every day, and that first step is thrilling.
And I'm afraid of heights, so this I have to really be. I'm not, but this is really scary.
It was a unique experience of the life.
To walk in the sky, it is something we feel we are on the top of the world.
Namaste. Namaste. Yes. Yes, huh?
It's a little dizzy for me, at least. You know.
It's gorgeous.
But it's beautiful.
It's gorgeous.
The Grand Canyon Skywalk, a living monument to showcase human imagination, natural beauty, and true engineering ingenuity. A visionary structure in a grand location where people can now fly with the eagles.